Ladies and gentlemen, hello, and once again coming to you not quite live from One Take Studios, where today we are going to have some fun. Today's topic is binomial probabilities. If you are currently taking an AP Stats class, this is probably not the video for you. We're going to focus more on understanding the concepts and how calculators might work instead of, we're not going to be working through these gigantic formulas for things. Alright, so binomial probabilities, what are they? Well, if we run a binomial experiment, bi as a prefix means two, and words typically have meaning. This means that we are going to have an experiment that has two outcomes that are referred to as success and failure. Two outcomes, success and failure. So this could be something like, I'm trying to shoot a goal for soccer, and either I make it or I don't. Success or failure, there's a probability for each. This could be, I have to randomly guess the last couple questions on my SAT test because I didn't have enough time to finish it. Well, success would be picking the right answer, and all of the other options would be just lumped together as failure because none of them actually give me points. So success and failure. These are the two things that we're talking about for a binomial experiment. Other features of binomial experiments include you will have a fixed number of trials, so the same number of trials for each situation that we've got coming up here. I'll show you an example in a second, so this will make some more sense to you. The trials are going to be independent. That means that the outcome of one trial should not be affecting the outcome of another trial, and they should also have identical conditions for those trials. I'm going to tell you right now, if we come upon circumstances where the trials are not quite independent and we're not quite identical conditions, they're going to call it good enough. Alright? So like if I'm shooting basketball free throws and all of a sudden identical conditions, a wind comes up because I'm shooting basketballs outside in the driveway, they're going to still call that as identical conditions. So anything that's close enough is going to be close enough in this case. Alright. P of S. That is a capital S because I wrote it that way. And this is the probability of success is the same for each trial. So the probability of success every time we run a trial is going to be the same. And again, I'm going to show you an example here in a moment that'll get you a little bit more solid for that. P, lowercase p, is the variable that is used to represent the probability of success. And so let's put a lovely pretty box around that. All right, that is a lowercase p, and that is the probability of success. Probability, that means it's an actual number. And then Q, because why not Q? Q is our other variable that represents the probability of failure. So both of these are numbers. So let's say that I've got a multiple choice test and there are four options. My probability for success is likely to be one of those four options, so 1/4 or 0.25 would be my probability of success. If one option is correct, that means that the other three options are all incorrect and would result in failure. So Q, or the probability of failure, would be 3 out of 4 or 0.75. So success, failure, P, Q, these are actual probabilities, these are numbers. All right, and notice that if I do 1/4 and 3/4 or 0.25 and 0.75, it adds up to 1 because this should be 100% of everything that can happen as an outcome for either success or for failure. All right, the goal in a lot of our problems then is we're going to be trying to figure out the probability of getting a certain number of successes out of our trials. Notice R is a variable here that indicates the number of successes, like how many successes, 1 success, 2 success, 3 successes, and then N trials is the number of total trials. So if I'm going to shoot a basketball 10 times, my probability of success should hopefully be roughly the same for each. And I'm looking for what's the probability that I make 5 out of 10 of my shots? What's the probability that I make 8 out of 10 of my shots? So looking for the number of successes, number of failures, what is that probability? All right, originally this was done with lots of tables and craziness and stuff, and the tables are pretty cool, and they result in formulas because you can find patterns in them. And I'm going to show you this just because I'm going to show you this. This right here is the probability for the number of successes. So this is what we're talking about here, the probability for a certain number of successes. This is a formula that you can use if you would like to crank some of this by hand. We talk about the number of trials, number of successes, how many combinations are there that would have that number of successes, and then the probability of excuse me, success to the power of how many successes there are, and the probability of failure to the power of how many failures there are. Ooh, that just doesn't look great. I'm going to make sure that you understand that that is n minus r. N minus r. All right. So if you would like to use that formula, you are more than welcome to. And I'm going to show you one with that formula, but then I'm going to show you some other options that are available to you as well. Okay, so example problem. Let's put some of this in context, shall we? 90% of women say that their mother-in-law is the biggest problem in their marriage, and 6 women are together and having coffee. Dun dun dun! I have borrowed this problem from my Understanding Basic Statistics textbook, published by Brace and Brace 5th edition, because this problem entertains me so much. You haven't met my mother-in-law. If you had met my mother-in-law, you would understand my obsession with this particular problem. The woman... I'm telling you that there's definite issues here. Someday we're going to have to sit down and have coffee ourselves and have a whole bunch of stories. But, like, okay, if you go out of the country and then come back in the country, you don't expect your mother-in-law to be in your house, having somehow found a key for the house, taking things that you made off the wall, putting them in the closet, and putting her own pictures up while you are gone. No, I'm not at all traumatized by that. All right, 6 women are having coffee. So, now what? All right, so... I've got part A here. I've got actually A, B, C, D. So we're looking at 4 different takes on this problem. So what is the probability that all 6 of these women dislike their mother-in-law? Well, if I set this up using this formula, the probability of 6 women disliking. Now notice what that means for this case, that in this case success is the percentage of women that are disliking their mother-in-law. So success is actually dislike in this case. Yes, you could rearrange it differently than that. All right, so we're talking about out of 6 trials, because there are 6 women, so those are 6 trials. We are looking for combinations of, well, I actually want all 6 in this case. If you know anything about combinations, 6C6 should tell you something very specific in your brain. There's only so many combinations that you can make when you have all elements present. Times, let's see, the probability of success is 0.9, so 0.9, and that was to the 6th power, because we're looking for 6 as our R right now at this moment in time. And then times, if 90% is the probability of success, then 10% is the probability of failure, and n minus r, 6 minus 6. So we're looking for combinations of 6 out of 6 women, where we've got 0.9, our probability of success to the 6th power, times 0.1, our probability of failure to the 0 power, because there are no failures. All right. If you crank this through right now, you get something, I believe it is in the ballpark of 53%. All right, so hold that number in your brain, 53%. You can run all that through the calculator. I would like to, however, have you experience something else here for a moment. So let me switch my screens over. I'm going to switch screens back and forth a little bit here. This is my TI Inspire CX, and this is just a basic calculation screen. We're going to go to where everything fun and exciting is, which is the menu. And let's see, ooh, we're doing probability right now. That makes sense. We are looking for different distributions of probability, so we're going to go to distributions. And ooh, if you look at the bottom, there's even a binomial option. Let's pick that one. That one looks like fun. Ooh, they want to know some things. What did we just run? We said the number of trials was 6, because we had 6 women. And the probability of success, we said that 90% dislike, and then the x. This right here, the x value, this is our random variable. This is our r. This is our number of successes. So we're looking for 6 successes out of 6 at a 0.9 success rate, and okay. Oh, hey, what did I just say? I said if we were to hand crank that formula, you would get 53%. Check this out. That's what that is. That's 53%. So 6 women, probability of success, 6 successes total. All right, so I'm going to switch my screens back again, just so we can take a look at this from a writing perspective, because this is actually going to be very important. We just said that we ran a binom PDF in the calculator. And we told it that the arguments, that's what these are called, arguments, that there were going to be 6 trials because there are 6 women, and that we said the probability of success is 0.9, and that we're looking for 6 out of the 6 women to dislike their mother-in-law. We cranked that through and we got 0.53 approximately, which is the exact same value that we would get from cranking this through in our calculator. Or I suppose hand cranking it if you really wanted to. All right, so calculator will run this. If you don't write this down, everything in the moment feels like it makes sense. You cannot trust your feelings. You forget 80% of what you hear. Every time I get a student that does not write this stuff down, they go back to their notes later and their notes are totally meaningless. So please, I encourage you strongly that if you are using the calculator, write down what it is you're putting into the calculator so that this has some meaning later and not just a bunch of scribbly numbers that don't do you any good. All right, so what would this change? What would this change for the probability that none dislike? All right, so probability that none dislike. I'm not going to run through this formula again because, quite frankly, I'm not going to run through the formula. Again, I'm focusing on understanding things, and I'm going to let the calculator do the heavy lifting. So again, I'm probably going to want to run Binomial PDF, and I still have 6 trials, because there are 6 women, and my probability of success is still 0.9, and I need a drink. Hold that thought. All right, so what were you thinking? What's going to come next? If we're looking at none dislike, what's this number going to be? Hopefully 0. We're looking for 0 successes. So last time we wanted to get 6 successes out of 6. Now we're looking for 0 successes out of 6. Knowing what words mean is helpful. And closing that off. So jumping back over to my calculator screen again, let's see what we can come up with. By the way, do you think that this is going to be a high probability or a low probability? Could I go back into the menu and go through all the menu items again? Yes, I could. Here's a time saver. I'm going to go up, and I'm just going to grab this thing and hit enter. Because I haven't changed anything right now except the last number, so I can just edit the last number. Again, I still have my 6 trials. I still have the same probability of success, but now I'm looking for what is my probability for 0 successes. And I hit enter. Oh my gosh, that's a small number. How many zeros is that? Let's see. We got 1, 2, 3, 4, 5. 1, 2, 3. I think that's 5. So we are talking 0.000001 as our probability that none of the women dislike their mother-in-law. Did you see that one coming? Maybe you did, maybe you didn't. I don't know. It should be really, really low because we're talking about 90% is our success rate. That's really high. And so to have all of them not fit the 90%, it's really unlikely that's going to happen. And so hence we see that number reflected here as a really low probability. There is one thing I'd like to show you while we are still in this particular topic. I'm going to go back to my menu and I'm going to show you, let's see, probability, we said distributions is where we're at, and here's our binomial PDF thingy-do. And what happens if I put in my 6 trials and my 0.9? But did you notice last time it said that this is optional? What if I don't put anything in here? What if I just click OK? Wait a minute, what is that? What is that? What is that? Oh, do you recognize that number? Look at the number that's right here. That's the 0.53. That was the probability that we had for 6 successes. What if I start scrolling back? There's another number, 0.35, 0.098. Keep scrolling, scrolling, scrolling. Oh, do you see it on the end there, guys? Do you see it? There it is. Look at that. If you do not put in a number of successes, the calculator happily obliges you by giving you all possibilities. So this first number before the comma is the probability of 0 successes out of 6. The second number is the probability of 1 success out of 6, and 2 successes, and 3, and 4, and all the way on up. By the way, how many numbers are in this list? 1, 2, 3, 4, scroll, 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 5, 6, wait, why are there 7 numbers in this list? I only have 6 people. Ah, but think, if 0 is an option, what could happen? 0 successes, or 1, or 2, or 3, or 4, or 5, or 6. So even though we only have 6 trials, we actually have 7 possibilities for outcome. And by leaving that field blank, we are giving all the possibilities for them completely and totally. All right, now, I'm not going to switch back to my paper just yet, but I'm going to tell you what's on it right now. The probability that at least 4 dislike the mother-in-law. The probability that at least 4. I cannot tell you how many people do not know what the words at least mean. Turn it into money. If you have at least 20 bucks in your pocket, what does that mean? You have $20 or more. So at least 4 dislike, that's 4 or more. Or That's multiple probabilities. That's saying that 4 is good, but 5 is good, and 6 is good. So that would be the probability of 6 combined with the probability of 5 combined with the probability of 4. So that's or we add, right? So this is like almost 10%. This is 35. So let's call that 45%. 45, that would be 98%. Ooh, that's like, if I just add those up, it's like 98% would be my probability of 4 or higher, because it's 4 or 5 or 6. Could I add these all together? Yes, absolutely I could. Or, let's go back to our menu for a second. There's something else that's there. All right, we are still in probability. We are still in distributions. But if you scroll just a smidge farther down this list, okay, oops, I've scrolled a bit far, underneath Binomial PDF, there is also a Binomial CDF that wasn't even on our screen until we scrolled and means something slightly different. Okay, do you have a pencil? Are you writing this down? Ladies and gentlemen, Binomial PDF is for calculating a single probability. The probability of 6 successes is a single probability. The probability of 0 successes is a single probability. Binomial CDF is cumulative. That's multiples added up. So when I say at least 4, that is cumulative. I want to go here. There's a slight change. Number of trials is still 6. Probability of success is still 0.9. There it is, 9. And let's see, my lower bound. Well, at least 4. At least 4, that means 4 or higher. That could be 4 or 5 or 6. There we go. So this is going to get me a total, a combined, a cumulative probability of having 4 successes or 5 or 6 successes. So lower bound, upper bound, and okay. By the way, if you're running a TI-84 right about now, you might see something slightly different, but it's largely similar. All right. Hey, guys, look, it's 98. And what did we say? We said if we added up the 53% from this one and the 35% from this one and the roughly 10% from this one, we would get 98. There we go. So PDF for a single probability, CDF if you have an interval, a range of probabilities, and you're looking for a combined total. All right, so jumping back to my page again, where am I? I am here. There we go. All right, so the probability that at least 4 dislike. We are still saying there are 6 women. We are still saying the probability of success is 0.9. However, we're going to have, instead of one argument on the end, instead of having one single probability, cumulative, we've got a range. At least 4 means 4 or more. In this case, that's 4 or 5 or 6 because there are 6 women total. And again, what did that give us? That got us approximately 98%. Which again is a logical probability because we're talking there's a really high success rate for this and we're adding up multiples. So yeah, that makes sense that we've got a whole ton here. Okay, one more, last one. Probability that no more than 3 dislike. No more than 3. Again, you've got to know what these words mean, guys. No more than 3. That means 3 at most. That means 3 or 2 or 1 or 0. Don't forget about 0. So that's, again, multiple probabilities, not a single. So I don't want to use PDF. I want to go back to CDF again. Binomial CDF, cumulative probability. Still 6 women, still have a success rate of 90%, but no more than 3 means 0 on the low end and 3 on the high end. 0 on the low end, 3 on the high end. All right, what is the calculator going to tell us this time? Let's see here. So again, I could go back into the menu and pull everything up that way, but I could also just say, hey, I'm going to go up a line or two here. Whoops, actually, I didn't want to quite do that. Hold on. Let me do this. I'm going to go up a line or two. There we go. And bring that back down and simply edit what I have, because I'm only changing the last 2 numbers in this case. We're going from 0 to 3. 0 to 3. Now, if you're really bright, if you're really paying attention right now, you may have noticed something. Let's hit enter. Interesting, interesting. So wait a minute. Okay, so this is actually more than 98%. This is almost 98.5%, which means there is a remaining, dun 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 dun, 1.5%. Did you notice I even did that to you? This is the complement of this. This is 4, 5, and 6. This is 0, 1, 2, and 3. This should account for all of my probabilities. And if I add these 2 numbers together, I actually do get all of my probabilities. doesn't always happen like that. I just felt like doing that. So again, if we round this at a 0.015, we would call that roughly 2%. And so again, for tracking that, jump back over to this guy, we're calling that roughly, approximately 2%. All right, a lot of things going on here. Hopefully the example kind of helped solidify things. Come talk to me if you want more mother-in-law stories. PDF versus CDF. Did you pay attention? Did you pay attention? Because there's two different types of problems here, and I showed them both to you. All right? Please be careful. Think carefully. Oftentimes, you can have more than one way to set these up, depending on your perspective. But if you are not careful, you can end up with some serious pretzel brain. That's what happens when your brain gets all twisted up from trying to think too hard. All right? So be careful how you set these up. Think, but don't overthink. All right? Got it. Awesome. Thanks.